For this last problem in section 2.3, there's a couple of interesting things going on the piecewise function. So the first thing that I want to take a look at is these two pieces of the domain. So instead of it being the normal domain, like on these problems where you had just like x is less than -1, you actually have absolute values as part of your domain. So we kind of need to revisit what those actually stand for. So when you've got the absolute value of x is greater than 2, remember from when we did this in our previous section, that actually means x is greater than 2 and x is less than -2. So think about what's going on. If x is greater than 2, that's everything on the right. If x is less than -2, that's everything on the left. So this is going to be my right piece of the function and my left piece of the function. Okay, so that's thing one. This one works the same way. This absolute value of x is less than 2. So I'm going to have x is less than 2. Separate that out. X is less than 2 and x is greater than -2. Well, if x is less than 2 and greater than -2, that means it's between those two. So you'll typically see it written this way. So you've got -2 is less than x is less than 2. Okay, so looking at those domains, because it's piecewise, this is everything to the right of 2. This is everything to the left of -2, and this is everything in between. But you'll notice none of these pieces have the or equal to part of your inequality. So there's gaps at -2 and a gap at 2. So that tells me that the domain of the function goes from -infinity to -2, where there's a gap. It goes from -2 to 2, where there's a gap. And then it goes from 2 to infinity. So it covers all of the pieces of the function, just not specifically at -2 or 2. Okay? Next thing on our list is end behavior. Okay? End behavior of the graph. We said that this piece was the left, this piece was the right. So if we write this in terms of limits, the limit as x goes to the right of the function. Well, if we're going to the right of the function, we're on this piece. So let's think about what this does, okay? Do you remember square roots graph like this? That's our parent function of a square root. When you square something inside of a square root, you actually get this other piece of the function, okay? And I would have you play around with that some on your calculator. Look at the square root of x squared minus 4. It's gonna make a graph that looks something like that. Also, while you're playing around with that, I would switch the 4 and the x squared and see what changes, just so that you get used to knowing what those graphs look like without having to actually graph them on the calculator. So they are going to do something like this, kind of looks like antenna. But as we're going to the right, this function is going to go up forever. So this function is going to go to positive infinity. And as we go to the left, the function also goes to positive infinity because you've got like the two antenna. So that's what our end behavior is going to look like. The next thing is our x-intercepts. Remember, x-intercepts occur where the two pieces of the function equal 0. So we'll set them both equal to 0 and see what happens. So the square root of x squared minus 4 equals 0, and 4 minus x squared equals 0. Okay, so doing the first one, we'll square both sides. So this will be x squared minus 4 equals 0. Add the 4, so x squared equals 4. Square root both sides, so we get x equals plus or minus 2. Well, if you look at this branch of the piecewise function, x actually cannot equal 2 or -2 because it's not the or equal to sign on the inequality. So this one doesn't work. Solving this one, we get 4 equals x squared, square root both sides, and we get plus or minus 2 again, which equals x. But on that branch of the function, we don't have the or equal to either, so this set doesn't work, so there are no x-intercepts. Okay, so make sure you're paying attention to what can and can't work on each piece of the piecewise function. For y-intercepts occur where x equals 0. Well, x is going to equal 0 on this section where the x is between the -2 and the 2. So if I plug in 0 to this, I get 4 minus 0 squared, which is 4. So the y-intercept is at y equals 4. Okay? Make sure you use the right part of the graph for that. What's next? Symmetry. Okay, so look at what's going to happen to both of these. If I plug -x into this function, if you ignore the fact that I already drew what that piece is going to look like, if I plug -x in, this piece is going to stay the same because it's squared, right? So this function is going to stay the same. So this function is even. If I plug this piece in, this is also going to stay the same. So that makes this piece even. So both of these pieces are even. So since the section that we're dealing with is equal to either side of the y-axis, because we go 2 to the right and 2 to the left, since this piece is symmetric and this piece is symmetric and the endpoints that we're dealing with are symmetric, this has an even symmetry. And if you graph that on the calculator, it'll be really, really easy to see. And then as far as discontinuities go, we need to check and see what kind of discontinuities these would have. So if I plugged these numbers in, if I plugged in -2 and 2, which is the boundaries that they reach at, the question is, do they go to the same place? So if I plug in 2, I get 2 squared minus 4, which is 0. If I plug 2 into this function, I get 4 minus 4, which is 0. So at 2, they meet up, okay? At -2, if I plug -2 in, I get 4 minus 4, which is 0. And if I plug -2 in, I get 4 minus 4, which is also 0. So that tells me that these two functions are going to meet up like this. They're going to meet up, but then there's a hole. So they're going to meet up like that. So this discontinuity is a point discontinuity. So it is a non-removable point discontinuity like we talked about in the last section. At x equals plus or minus 2. The same thing is going to happen, okay? So then the last thing that we have to do is graph this thing. Let's take a look at a graph. Okay, so I know, just because of my knowledge of functions, that this is what the graph of the top piece is going to look like. And that's going to have, it's going to hit 0, we said, when we plugged in -2 and 2, but there's a hole. So if I go to 2, there's a hole at 0. If I go to -2, there's a hole at 0. And I know that these two pieces, the outermost pieces, because I know what functions look like, they're going to go like this. If you don't remember what those look like, you could graph them in the calculator, or you could plug in points, right? So we could plug in a value for x, something larger than this. So like 3, if I plug in 3, that's 9. 9 minus 4 is 5. So the square root of 5 would be the point there. So you could graph some points and see where that goes. And then 4 minus x squared. So this is a parabola. It's a downward facing parabola that begins at 4. So 1, 2, 3, 4 begins at 4. And I know that at -2 it should hit 0. And I know that at +2 it should hit 0. So this is what the graph of this piecewise function looks like.